and tell me what is average deviation. What is the average deviation here? So here I try to capture that how individually have how each and every individuals have secured more or less marks than the average. This is what I tried. How each and every individuals have secured more or less marks than the average. This is what I tried to map. This is what I tried to map. Now I need one figure, which is a generalized figure. Now find out the average. Add all this and find out and divide it by total number, that is 5, and tell me. 8.4 minus 26.6 plus 5.5, 88.4 plus 4.5 divided by 5. Tell me, what is the figure? 0. Why? Why? Now 0 tells me that deviation from mean is 0. That means when I try to map that how Anisha has secured more marks than the average marks, how Suresh has secured how many less marks than the average, in what way Pammi has secured, or let's say how many marks Pammi has secured more than the average, but above than the average, or Sai Hemanta above the average, but ultimately the result is 0. Why? Because of this negative value. Negative value won't allow us to, so negative value this way can be hurdles to summarize it. If you want to summarize the mean deviation, then let's say if you want to draw any generalization based on the mean deviation, average value, negative value will create hurdle for you. Lots of hurdles for you. And you won't get the exact variability. You won't get the average variability. What to do now? That's why scientists, to nullify the effect, they have tried to find out the square of it. Now you just try to find out the square of this. Try to find out the square of this and tell me the figure. Try to find out the square of all this and tell me. This is a mean deviation. Mean deviation. How each and every individuals have secured more or less marks than the mean. ये चीज mean deviation बताएगा. Now the first one is 70.56. Is this 707.56? Now this is 29.16. ये क्या आएगा? 70.56. And the last one is 19.36. But this is what? This is basically xi minus x bar the square. It's okay. Let's find out the sum. Let's find out the sum. That means we are trying to find out I running from person number 1 to person number 5, and we are going to find out summation of this quantity, summation of this particular quantity. What is it? 70 plus 56 plus 707.56. Tell me the summation. The summation is 897.2. Now let's divide it by number of person, that is 5. What is this quantity? $179.44. But our marks range is 0 to 100. If we talk about the range of the marks, the highest marks can be scored as 100 and the lowest possible marks is 0. But this is a square quantity. This is, we just try to understand that how individuals, each and every individuals try to score, how each and every individual score is far from the average. In order to map that quantity, we just find out the square of it. It's like very simple. When you deal with this -2 number, okay, what you can do, find out the square of it. That means it'll become 4. Again, you want back this particular 2 figure. Okay, put a square root. This way -2 to 2 can be converted. Let's put this is variance. This is called variance. This is variance. Now standard deviation is nothing but under root of variance. Variance is a square distance from mean. Variance is nothing but the square distance from mean. So this is a deviation, 30.39 marks ka deviation is there. So when you discuss this story that the average performance of this 5 student is 86.6 marks, please mention that the deviation is of 13.39. So the average deviation from mean is 13.39 marks, which is equals to 13 marks. Okay. The average performance, you can say approximately 87 marks. Arindam, there is a concept in mathematics. Let's say I have 10 rupees. Okay. And Arindam, you're having 12 rupees. Okay. Let's find out the difference between the money we are having. If I put the figure of money that I am having first, and then if I, let's say, put the figure that money you are having, if you are having more money than me, the figure will be negative. But -2 rupee, it's not an interpretation. In many times in real world, let's say the negative signs do not mean anything. So how to reduce this sign? Okay. Got this? Arindam, got this? Is it clear to all of you? Yes or no? Are you clear with the standard deviation? Yes or no? Confidently? What is a variance? Tell me, what is a variance? Variance is showing the distance, on an average distance from the mean. But what kind of distance? It's a square distance. It's a square distance. It's a square distance. Tejas is asking that what is the relation of variance with the mean deviation? Summation of all mean deviation. See, these are the mean deviations. These are the mean deviations. For the Anisha, this is a mean deviation figure for Suresh. This is a mean deviation figure for Pammy. This is a mean deviation figure from Siddharth. This is a mean deviation figure for Sai Hemanta. Mean deviations are showing that how each and every individuals have scored more or less marks than the average. Because here the Suresh is the only one who has secured less than the average. Otherwise, all the students have selected, I mean, they have, scored more marks than the average. But again, one student has selected, one student has secured, let's say, less than the average. The figure is like negative here because average figure is bigger than the marks he has secured. So to nullify the effect of negative value, if we go with the negative value, the summation of mean deviations won't give us a true picture. Why we are finding mean deviation? Because here we just try to find out the average. Average is not satisfactory. Or let's say if we go with the average, we are not justifying with many students. Like 4 students have secured more than 90 and the average is 86 point something. Okay. So this average figure is not a true representative of these 5 values. That's why mean deviation. To understand how the actual figures are deviating from mean, how actual figures are far from mean. That's why mean deviation concept exists. And that may at least give us a negative value. That is the only reason we just try to find out the square of it. And the square quantities ka summation is a variance. Okay. Understood, Tejas? Arey yaar, Tejas, why we can't find out the standard deviation straight away, because we'll get the square distance, Tejas. Then only we need to put it in under the under root sign. If we put them in an under root sign, then only we'll get this 13.39 marks. Otherwise, based on the variance, 179.44 marks. How that can be possible, Tejas? How this much variation could be there in the data? Because our range is student can maximum score 100 marks. Understood, Tejas? Yes or no? Tejas, you are not writing anything. Tejas, this is a variance formula. This is the variance formula. I guess you are the only one who is confused with this. This is a variance formula. Is it clear, Tejas? Except Tejas, how many of you? Okay, Tejas is also convinced. Okay. Are you clear with this? Now you just tell me, if you were in my place and if you supposed to generalize this data in one sentence, what would be your sentence? What would be your sentence? Now you have a mean figure, now you have a standard deviation figure. Generalize this in one line. Okay, Sai Hemanta is asking mean absolute deviation. No, 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 no. They are same. Sai, that way we just try. Okay, Sai, that way we just try to put the. Okay, there's a concept. It's like in the modular sign. If you put this in the modular sign, it's like positive values can be considered this way. Let me just rewrite that column again. So this way you can rewrite column. This is called absolute this is a modular sign. This is a more modular sign which consider only positive values only. Okay, this way you can at least. Okay, so maximum students. Arey Ravi, this is like generalization. Just tell me the one line interpretation of this. One line interpretation of this. I guess Rajesh has written something. The average marks of the class is 87 with the standard deviation. Mean is not required. Standard deviation is of 13 marks. Average of 5 student is 87 marks and they deviates by 13 marks. Yes, yes, correct. Yes, correct, correct, correct. Superb. Okay. Now let me just talk about now in case of sample, this is going to be a formula. In case of sample, okay, so this is a sign of variance. Variance can be denoted by S square. Okay, this is a sample variance notation, and standard deviation is known as SD. SD, standard deviation. Okay, this is a sign or the symbol equals to under root of S square. Got this? Got this clarity? Yes, there's a huge difference. Tejas, I hope now you have to understand. See, this part is this part. Observe this part. If you remove square, this is a mean deviation. I mean deviation or difference, deviation from mean, deviation from mean. Got this? Are you clear now? Lena, why we need to find the standard deviation? I have discussed that. I've already discussed that. Ankit, why it is n minus 1? In the case of sample, in the case of sample data, in case of sample data, you have to put the n minus 1. In case of population, you should put n only. Because in sample, the concept is called degrees of freedom. Okay, degrees of freedom. Degrees of freedom. That's why. So in all the calculation of the, in most of such calculation of the sample, the denominator part, this is a denominator part. In denominator part, we just put the degrees of freedom. That's why. I'll explain what is degrees of freedom. First of all, you just allow me to at least, let me just discuss through one very simple example. Okay, I guess you can see this, right? Just a moment, just a moment. Okay. So these are the companies, number of US cars in the service by the top car rental companies in the recent year according to the auto rental news follows. Okay, if we follow this particular news, then these are the number of companies in last 1 year. They came to the service center and they have serviced this many cars, right? Now you just tell me the average figure. These are the companies, and in front of these companies in the other column, the variable is number of car in service. Tell me the average number of car in service. Okay. Maybe I don't want to see the data. I just want to look at the summarization that, let's say, per company, how many cars in service are expected. How you are going to answer this question? Let's say I just want to know that per company, per one company, or let's say what is a normal figure of number of cars in a service per company, or let's say how many cars in service are expected per company. If you are owning a company, how many cars are expected in service for one particular year? Okay, take the average. Okay. we'll take a break. Okay, we'll take a break. Don't worry. We'll take it. Don't worry. Just give me 5 minutes. This is the average. Okay. Can you tell me the range? Can you tell me the range? The highest number of highest number of cars in service is registered for highest number of cars in service observed for enterprise. Okay, and the lowest number of observed for triangle. What triangle? Let's find out the variance. Now, variance can mislead you because that's a square quantity. Variance of P. Okay, let me just select the array, hit the enter key. This is a variance. The lowest number of car, or let's say the lowest figure of car in service is 6,000. So in triangle, okay, in last 1 year, okay, there were 6,000 cars, which was the lowest figure observed for the triangle, and the highest cars in service observed for enterprise, which is 6.43 lakhs. Now, what is this variance? Difference, I mean, the average is what? 1,37,000, roughly 1,37,000 cars in service are expected per company in US. What is variance? Variance is so big, I mean, it's falling outside the range. This range is 6,000 to 6 lakhs. And this is variance because this is a square distance. This is a square distance. That's what I'm saying. Observe the formula of variance. It's a square distance. It's a square distance. How each and every point, how each and every xi is far from mean. We find out the square of it. Okay, how to find out the variance? Okay, I'll tell you. See, if this is a population data, this is the formula. If this is a population data, then this is the formula. If it is a sample data, this is the formula for the variance. I hope you can see this. Have you noticed this? Have you noticed it? Yes, no, I need some answers. Okay. Now standard deviation. Because variance is a square distance, and it's like we get confused with the square distance from the average. When the average is 1,37,000, it's like normal figure that, let's say, if you start a company per year, this many cars are very normal that may come to your service center. 1,37,769. Okay. What is the standard deviation? For that, this is the formula STDVP. Okay. Note down this particular thing, STDVP. Noticed? Have you noticed that? This is a formula. Have you noticed it? Yes? Now you just tell me, what is a deviation? What is a deviation? Deviation is so huge. Why? Because there are many companies, okay, after budget, okay, after this, let's say there are many companies, okay, for which, let's say, number of cars in service are like relatively very less. You can't compare triangle with herds or AVs because there is no comparison. Here in a year, in a typical year, 6,000 cars normally arrive for the service, and here it's like 2 lakhs or 3 lakhs. So that's why the average is 1,33,037,000. But again, based on this profile, you can say that average number of cars, let's say if you let's say owning a particular service center, then in a typical year, 1,37,769 cars are expected to arrive, but the deviation is also very high. Okay, what is the deviation? 1,79,541 cars का deviation is there. Got this? मतलब ये average number of cars आपके वहां आ सकती है और deviate हो सकता है इतना, which is too high. Why? Look at the data. These are not at all comparable figure with the upper part. Got this? Yes or no? Yes or no? Okay, here we take a 5 minutes of break. Within the break time, if you have any questions, please go ahead with your questions. Priyanka, Priyanka, for notation you should know if it is a sample. These are the standard notation used by many books. If it is a mean, population mean, if mean can be calculated based on the population data, it's known as mu. This is called mu. Mu. Start with. It's, you can pronounce like this way, mu. Okay, Priyanka? And the standard deviation can be denoted by sigma. This is called sigma. Okay, can be denoted by sigma square. Now in case of sample, it's like x bar standard deviation can be denoted by SD, and variance can be denoted by S square. Clear? Is it clear? Now here the formula of S square equals to nothing but summation of mean deviation ka square, summation of mean deviation ka square divided by n minus 1. Here sigma square ka formula is summation of xi minus, matlab summation of all mean deviation and its square divided by population, total units in the population. Is it clear now, Priyanka? Can we ignore the less number and take the average of others? Daban, it's like very practical approach. Many times we can, many times we can't. Okay, depends on the research methodology. That depends on the research methodology, whether you can partition your data or not. Okay. Can you use formula in Excel instead of using Excel shortcuts so that we can simplify? What kind of formulas? I have shown the formulas. Ankit? Reena said, can you go to the previous page? Simple and better, thanks. Sudhir is asking why we take a square, Sudhir. Now this is like, I mean, I have discussed it so many times. Why we take a square? Because look at the Suresh,